All right, LeetCode number 11, container with most water. So what we got here, think of these as walls. These are the indices in an array. You're given an array. And these are going to be, this is the height of, just think of it as a wall. And what we want to do is, what are the two walls that can contain the most water? So what we're going to do is we're going to find, like, this is 7, so your answer is going to be 49. Because what you're going to do is you're going to take the smallest wall, because if it was like this one, the water would only rise up to the smallest one. So what we do is we take the smallest one and then we count between the indexes, and we're going to, or indices, and then we're going to call that the distance. So we'd have here 1, 2, 3, 4, 5, 6, 7. So 7 times 7 is 49. We can't go off the 8 because it can't rise that high. If we went to here, 8 and 8, 8, 1, 2, 3, 4, 5, 8 times 5 is 40. That's less than 49. That's not the answer. So this is it. C sharp. Let's do it. Uh, okay, first of all, the height. This is, I don't like that wording, so I'm going to call it container. Those are my wall sizes. Okay, the first thing we do. Um, Let's check for less than 2 walls. So if, I don't know if LeetCode's even testing this, but this is what I would do anyway. Okay, container dot length. It's a property, not a method. Dot length is less than 2. Let's just return 0. Okay, got that out of the way. Let's comment it. Uh, at least 2 walls. Okay, so what do we need? We need some variables, obviously, because we're going to use 2 pointers, one on the left, one on the right. We're going to scan them towards each other, and we're going to find the smallest index and then the distance, and we're going to calculate our volume. That's how we're going to do that. And we're going to throw it all into a temp variable that we're going to return at the end. That's really it. So what do we need? We need to initialize our pointers. Let's just make them ints. Remember, -1, because we're starting from 0, but the count doesn't. So here we go. We need our max. This is going to keep track of our the highest volume. So there. What do we do now? We've got our pointers. We need to what? Iterate. And that means what? If we're going through every element, is a O of n solution. So, wow. Left is less than right. Not less than or equal to right, because we don't want left and right to be equal on the same wall, because then we don't have 2 walls and we can't contain water. So less than. Okay, so what do we got to do now? Well, we need a volume variable. Start off at 0. Then what do we need? We need to calculate our distance. Remember, right minus left, because the right one's always larger than the left. We're talking about the indexes here, the indices. I don't know why we just don't say indexes. That doesn't sound bad. I mean, why have another word for it? Okay, back to this. Okay, so now we need to find the smallest one, the smallest wall. Okay, if the left is smaller than right, now we need to calculate our volume. In other words, what's the area of this little rectangle or whatever we got square? Area between the walls. Um, Equals what? Container left times our distance, which is the difference between the left and right indexes. Indices. Okay, we got that. Now we need to increment our left pointer. Okay. Remember, we're moving these pointers towards each other and calculating everything up. So now we have an else, and this is just the other side of the coin if the right side is smaller. What is it, less than? Actually, we don't need that. What am I doing? Calculate distance. I was almost doing a comparison to see which was smaller. Okay, container right times distance. And then we need to subtract from the right to make it smaller. Okay, so we got that. We've got our volume. What do we do now? Adjust the max volume found. So if it's greater than max, we're just going to adjust that out. Then max equals volume. Here we go on that. That's it for that. Where's our while loop at? Where's it? Nope, that ain't it. Okay, right here. Okay, so once we come out of the while loop, we're going to return max. Whoops. Ah, butterfingers today. Okay, we got all that. Remember, I changed height to container because it made more sense for me. We got our value. Should we run test cases or did we get it? Ah, you know me. Let's do it. 1 millisecond, beast 99.95. That's it, guys. That is the solution there in C Sharp. Like, share, subscribe, make a bumper sticker, and I'll see you on the next one. Bye.